Deep Generative Models. An Introduction to Generative Models. Greetings, budding machine learners. Today, we are going deep into the fascinating world of machine learning, specifically focusing on the concept of deep generative models. By the end of this session, you should be able to understand and appreciate how these powerful models not only learn and understand patterns and regularities in input data themselves, but also use that knowledge to generate entirely new and unseen data. To start off, generative models are a class of unsupervised learning models that learn to capture the true data distribution of the training set. This knowledge allows them to generate new examples that could plausibly come from the same dataset. Deep generative models take this a step further. These models use deep learning techniques to improve the precision and variety of their outputs. They are used to generate data in any domain such as images, music, speech, and prose, making them incredibly useful in a variety of fields, including arts and creativity. These models function by capturing the joint probability distribution between observed and target variables. Once learned, it generates data from this joint distribution, thereby creating new data that follow the same statistical properties as the training data. There are several types of deep generative models that are widely used today. These include variational autoencoders, generative adversarial networks, or GANs, and autoregressive models like pixelRNN. These models have found a tremendous use case in image processing. For example, given a database of human faces, these models can generate new images of human faces that have never been seen before. In the field of healthcare, these models can be used to generate synthetic medical data for training other machine learning models, especially where real medical data may be scarce or sensitive. An interesting but challenging aspect of many AI tasks is uncertainty. Deep generative models provide a way to model this uncertainty. Taking the example of GANs, these models involve two components: the generator network and the discriminator network. The generator aims to fool the discriminator by creating data that mimics the real data, while the discriminator tries to distinguish between real and fake data. This competition aids in refining the model over time. Variational autoencoders provide a mathematically well-defined framework for generative models. They function by encoding data into a latent space from where the decoder reconstructs it. The latent space captured and encodes the meaningful structure and relationships in the underlying data. Despite their benefits, deep generative models can suffer from issues like the mode collapse problem, where the model generates a limited diversity of samples. GANs, while capable of generating high-quality images, do have a complex training process. It's often unstable and requires careful selection and tuning of the model's hyperparameters. Applications of deep generative models are vast, including image inpainting, text-to-image synthesis, style transfer, image-to-image translation, and even anonymization by generating synthetic data that preserve properties of original data but don't reveal sensitive information. The objective function for training generative models is often a logarithmic likelihood measure, with an exception for GANs, which use a min-max game theoretical objective. Training of deep generative models poses unique challenges. For example, training often involves optimizing over two different sets of parameters jointly. In GANs, these are the generator and discriminator networks. This joint optimization can lead to high variance issues in gradient estimates. To sum it up, deep generative models, while complex, offer incredible capabilities, not just in understanding the content of images, texts, sounds, but also in generating new, never-before-seen content. They are an integral part of the machine learning landscape, and it is an exciting time to further explore and innovate in this space. In the next session, we'll continue our journey into the world of machine learning by focusing more on each type of deep generative model, starting with generative adversarial networks. Keep up your enthusiasm and get ready to further deepen your knowledge.